All right. Okay, Mitch, you are up first.
Oops, I'm sharing the wrong page. Hold on just a moment. Let's try that again. There we go. That should look a little bit better. Can everyone see my design doc?
Yep.
Yeah, can you zoom in by like 125% or 150%? The text is a little small.
Yep. Let's see here. How's this look?
Yeah, perfect. Thank you.
Cool. So spent my Christmas break sort of working over how upgrades are going to work in the ambient space. And particularly, I had some help from Stefan Prodden at Weaveworks, works on the Flux tool and has helped us with thinking through our upgrade processes in the past and putting out some best practices. Probably the most important part of this document is going to be the requirements. While there's a lot to talk about in ambient upgrades, this document tries to focus very specifically on how the waypoints will be upgraded. There are others working on like Z-tunnel upgrades and things like that. But this seemed to be an area that we hadn't spent much time on at this point. So also this document is really focused on the fleet perspective rather than the individual waypoint being upgraded. What I mean by that is if I have a huge cluster with hundreds or even thousands of waypoints in it, how do I move all of those waypoints gracefully from version A to version B? How do I decide when each waypoint upgrades? There's another equally interesting question, which is when I'm upgrading a single waypoint, how do I do so in a controlled and safe manner? Is there a way to, like, say, run two versions of one waypoint and traffic shift between them? That's very interesting. We should definitely look at it, but it's out of scope for this document. Trying to keep a fairly limited scope on the fleet here. So just 4 requirements. And I'll go through them one at a time and pause for questions because these are fairly important. The first is that we do need to follow best practices in orchestrating our waypoints. This is not just upgrading, but running. We need horizontal pod autoscalers, which will be responsive to load placed on the waypoint. If it's getting overloaded, we should scale up and add more instances. And pod disruption budgets are another best practice. Those are sort of brought up as examples. If there are other Kubernetes best practices for running a deployment, we should be leveraging those as well, and probably allowing the user to modify them. Certainly an HPA needs to be user customizable in order for them to say like what the max number of instances they want running of this given waypoint are. So questions on requirement 1 there?
Okay, I think from my perspective, when I'm looking at waypoint upgrade requirements, I guess I would be less thinking about like underlying implementation, right? Whether we're using HPA or pod disruption budget, I would be more thinking about, okay, I should be able to decide when to upgrade my waypoint. That should be independent of my control plane. And I should be able to upgrade my waypoint without causing any downtime to data plane traffic. At least there should be an option for that. So I'm more thinking about the higher layer user requirements.
Yes. So some of these further requirements will get to that. The one that is out of scope is the remaining available through the upgrade process. That is a valid requirement that just needs a separate doc. Because this is sort of focusing on the fleet perspective, when to upgrade each individual waypoint in a fleet of waypoints. It's not so much focusing on, okay, we've decided to upgrade waypoint X. How do we keep it available through the whole process and serving traffic? That'll be a separate doc. Does that make sense, Lynn?
So are you more targeting in-place upgrade? There will absolutely be downtime? Is that
This
what you are
document is just agnostic about what happens to an individual gateway as it upgrades. Whether that's in place or whether they're side by side, we've got to have a separate design for that. What this says is if you have 100, how do they all get upgraded? Do they all just upgrade whenever you upgrade your control plane, or is there some more fine-grained control? And what does that control look like? Does that make sense?
Okay, got you.
So the reason for focusing on HPAs and PDBs is that effectively those use the same mechanism as an upgrade. If you'd like to change something about your HPA, that's changing something about your waypoint template, which is effectively an upgrade. It may not be an upgrade that changes the version of the waypoint that you're running, but it's an upgrade that changes something about that orchestration. And so IstioD needs to be sort of involved in that if it's going to be dynamically creating HPAs and PDBs on the user's behalf. And likewise, requirement number 2, these are probably not in a priority order. I've sort of buried the lead here, and I apologize for that. But resource requests, just like HPAs and PDBs, customers need to be able to customize the resources allocated to Envoy within a single instance of the waypoint. That's one of the key advantages to the ambient model, is that we can be more responsive. We're not dealing with the sidecar model where configuring resource requests has to be done globally. Instead, they should be able to do this on a per waypoint basis, right? So if one waypoint is going to be really heavily utilized, give it a ton of CPU or memory or something like that. Third requirement, by default, and this one's a little bit controversial. John and I have a comment thread that you can follow to sort of understand the discussion there. But by default, all waypoints must upgrade when their control plane does. What this is just saying is, like, if I don't do anything to customize my deployments and I upgrade Istio in ambient mode, my waypoints should also get upgraded. Right now, this requirement is not fulfilled. So if you deploy ambient today and get a couple of waypoints going, and then let's say you do a minor version bump on the ambient, you've got to do your own, because obviously we don't have any releases yet. But you can simulate it just by publishing your own tag. I have tags ambient and ambient 2 that I've published for my images. If I upgrade IstioD from tag ambient to tag ambient 2, even though the templates upgrade and anything else, new gateways that I create will get ambient 2 version of the waypoint. However, all of the existing gateways will stay with ambient 1 until they are deleted or something else. And that's not like deleting a pod. That'd be deleting the deployment, forcing it to be recreated. So that's not ideal. Ideally, we'd like sort of the same upgrade process that Istio users take today to upgrade all of their mesh. I think it's just an oversight. A lot of this stuff was pulled together pretty quickly over the summer and was not necessarily meant to be production quality. So this is sort of just a requirement that we finish getting it to a basic production quality.
Okay, so I think I have a comment on the third one. I don't agree by default all waypoint must upgrade when their control plane does. I think that potentially could be an option, but I just think it's super dangerous as a default behavior, especially you are introducing downtime to the waypoint upgrades also.
Yeah. So one question that I would have is, what would we do by default if we didn't do that?
I mean, user can choose when to upgrade. I think it's much safer, and also they should be able to choose which waypoint to upgrade and at the right window, right?
I totally agree with that. And I think if you look at requirement number 4, that's still possible. This is just what is default.
Yeah, that's the default I don't agree with, given you have a downtime. Yes, I agree with number 4. I just don't agree with the default, and I think it's going to cause a lot of surprise for people, in my opinion.
What should the default be then? Because you said users should be able to choose. They are able to choose, but what should the default behavior be?
I would want them to choose so they know they are doing upgrades instead of they have to
introduce waypoint upgrade as like a mandatory part of a mandatory step of the upgrade process.
Yeah.
I mean,
Okay.
it's kind of
Could
like sidecars, right? Like we could have implemented something that goes to your sidecar and restarts it for you. We could do something like that for waypoints. We didn't do it for sidecars. It's maybe there's different reasons to do or to not do it for waypoints.
Okay. Within the same upgrade operation. Yeah, that's a good comment, Keith, that the control plane is not necessarily the right timing. Okay, so we have a little bit of further discussion to go on defaults and exactly what the default behavior is. That's not really essential to this design. The design introduces capability for users to customize all kinds of things. We can come up with a different default if we like. But I'll go ahead and move forward, kind of taking that as a note that we'll sort of come back to once we understand what our capabilities are. We can discuss what other defaults might make sense. And of course, the last requirement, which is the one that is probably the most unique from how Istio has run in the past, is that users must be able to run different versions of the waypoint for different gateways. This is something that was accomplished previously using revisions. So for every version of the sidecar or of a auto-injected or pod-injected gateway, you needed to have a different revision or different control plane running. This would look probably different from this, although the requirement is a little bit on the vague side. And then again, whether waypoints can stay up and available during an upgrade of an individual waypoint is a super important question that needs a whole separate doc. It's too important to sort of tack on to this one. I think they should be, for what it's worth. I think it should be hitless, but just need other space to work out that question. So this paragraph, oh, go ahead, Lynn.
Quick comment for your fourth bullet, right? Users should be able to run different version of the waypoint for different gateway. Would that be like for the service producer? Because I guess I'm having a little bit mental hard time to transform waypoint for the gateway was waypoint for the service, right? The producer service.
I don't know what a producer service is.
It's like full cost bar, right? And in that context, bar is a producer, service producer.
Okay. So when you define a gateway using the Kubernetes Gateway API, you need to specify that it's typed. Sorry, maybe I should add a clarification to this document.
Okay, so you're referring to the Gateway API. Okay, the spec. Okay, that's why I was confused.
Yes.
Yeah, I was thinking
and particularly only the ones that represent waypoints in the ambient model. I don't know if we're using waypoints the same way for ingress and egress in ambient. I've not seen a design on that yet.
We're not. That's why I was confused.
Yeah, I don't know. So this paragraph I won't go over in detail. It just covers why today waypoints don't actually upgrade, and has some serious typos in it. Okay, next up, the naive implementation would be sort of the default that we already sort of discarded. That you upgrade SDOD, it's going to go through, find all the waypoints, and upgrade them to the new version right away. I think it sounds pretty universal that is not a desirable workflow for customers. So we can pretty easily discard that, it sounds like. Is that right? Okay, I'm not hearing objections there. One thing that I explored with Stefan is better GitOps control. We really want to design whatever this process looks like in mind with best practices for running things on Kubernetes. And GitOps has emerged as a pretty serious standard in that space. So one way to do it would be when you create a gateway object, you need a waypoint deployment that corresponds to it, right? One way to fulfill that would be to define that in GitOps. So you create a gateway in Git, and then in Git, automatically, based on some sort of GitOps workflow, a deployment is automatically created. What's cool about that is that all of your deployments are accessible in Git. Any modifications you do would go through your standard GitOps flow. What's not so cool about that, any gateways that get created in the cluster that don't exist in Git, that for some reason bypass GitOps, which happens frequently, don't actually get deployments associated with them. They don't execute, which is bad. So advantages here are that everything exists in Git the way that it's supposed to. Disadvantages are that the cluster is less responsive. You cannot bypass GitOps control and still have a working deployment of Ambient. The last alternative here is the one that I would recommend. And this would involve adding probably 2 CRDs to control an upgrade process for Ambient waypoints. One of the CRDs would just represent a waypoint template. Today, the waypoint template is specified as part of the sidecar injector config map, sort of buried deep in the config and difficult to edit. This would just promote it up to a first-class citizen that we can have many of with different names. So you could have, and these names would be customizable by the user. We could do some defaults, like every time you put a new version in the cluster, we write a waypoint template named that version. But they could create their own templates with their own names for like high performance gateways and low performance gateways, and who knows, you know, what sorts of customizations they want to apply here. But these are just named templates. Then a given gateway would be mapped to the template that it should use by use of a label selector. So a waypoint selector CRD would just be a label selector combined with a reference to a template. When a gateway is created, we find which waypoint selectors match, hopefully only one, or maybe we need to add priority so that in the case of multiple matches, we can select the correct one and have deterministic behavior. That points to a single template, which is used to create the waypoint. And that template can include a deployment, horizontal pod autoscalers, PDBs, whatever is needed for execution there. So the last paragraph here walks through what a large upgrade might look like for a user. If I have, say, hundreds or thousands of waypoints, I likely would have one template for version A and one template for version B. I'm already on version A. I want to get to version B. I would advise that a user have lots of waypoint selectors, let's say 10. Maybe they would call them waves. Again, this is totally customizable by the user, but just showing one way that it could be used. So if you have waves 1 through 10 in waypoint selectors, and all of them are currently pointing to version A, you could upgrade your entire cluster by going through them sequentially and modifying the template to point to version B. So when you upgrade the wave 1 waypoint selector, all of the wave 1 waypoints upgrade, and you wait some period of time to see if wave 1 was successful, then move to wave 2. It gives them a predictable order and cadence throughout all of their mesh in which these upgrades are going to occur. But again, customizable by the user. If they don't want to use waves, if instead they want to go namespace by namespace or something else, this would be up to them.
Mitch, so is the general expectation that users are normally just switching the version here?
I'm not so sure about that. Like, there's a lot of performance tuning that you can and may wish to do to an Envoy proxy that they may want to do through templates and selectors. I think we probably ought to also have a mechanism to override that using annotations. So like this, if all you need to do is modify gateway requests for resource requests for one gateway, you do that through annotations rather than spinning up a whole second template that then you've got to manage lifecycle for and things like that. But does that answer your question?
Kind of. I guess I'm not sure if this is known or if this is obscure feature only I know about, but how it works for sidecars. And remember, waypoints are injected, right? I forget. Oh no, they're not injected.
Not injected, not through
okay, so I mean, there's kind of like these like varying similar things. There's like the gateway ingress, which is injected, but probably shouldn't be injected. It's really only injected so that we can do upgrades because we don't have what's proposed here. And then there's waypoints, which we know, and then sidecars, right? In sidecars, there's kind of two knobs that can already do similar things. You have templates, which you can select. So the default one is obviously sidecar, but you can actually add a custom one and then apply multiple templates as well. So you could say, I want to start with the base of sidecar and then add my extra resource template, right? And then you also have another knob, which is the revision, which normally, I mean, in theory, you could have like the latest Istio injected and set an older version based on template, but you'd probably select first the version based on revision and then your customization based on the template. The thing that may be missing is the ergonomics, though, because it's all in one config map. One shared config map, which is hard to modify if you're not an admin. But a lot of the building blocks are there. So I do wonder if those are something we could potentially use. And now injection, that's for injection, but we could also do it statically, basically like statically inject into a deployment, right, and then apply. The other thing is we should have consistency, like all these problems you're talking about, the exact same ones apply to gateways too, even beyond Istio. So it would be ideal if we had consistency between those, at the very least between the Istio gateway and waypoints. But if we can find a common ground amongst other people, that would be awesome. Obviously, that's a much bigger ask, though.
If only there were some people from the Gamma project here who might be able to help move that along.
Yeah, we've talked about it a bit, but not much. I just asked again if anyone else was doing this. I think we're the only one that has customization, and which is this like hacky mechanism with you select the template by annotation, by the way. I haven't got a response, but I just asked it like 10 minutes ago. So we'll see if there's been any progress that I'm not aware of.
Thanks. So I see a whole bunch of hands raised. Sudi, I think, is up next.
Okay. Yeah, so most of the Istio upgrades are mostly in place upgrades. So I was just thinking, as in, if we do a canary upgrade for the control plane, then how would this templates would actually behave? And as well as, let's say, I mean, you think about a scenario which is like after 4 or 5 revisions, I mean, it'll mostly become very complicated, and we have to think about like many templates here. So that might be cumbersome. The second thing that I wanted to talk about is, are we pushing the upgrades down to the users? And when we say users, what do we mean? The applications or all the persons who are actually managing the platform? So who are the actually intended users here?
Those are excellent questions. Let me see if I can get to them in order. If you have a bunch of revisions, or you try to do a canary-based upgrade with multiple revisions, and you are explicitly using waypoint selectors for all of your waypoints, so nothing is falling back to a default, especially since we don't necessarily have consensus on what that default behavior should be. That revision-based upgrade will not affect your waypoint in any way as far as execution goes. It may change which control plane it's communicating with, based on what revision it's a member of. But the orchestration, the deployment, the HPA, all the resource requests, everything like that would be unchanged because it's defined by your waypoint selector and template. The only time those parameters would change is if either the selector or the template changed. Or actually, I'm sorry, one other scenario, the labels on your gateway. If you change the labels on your gateway such that it matches a different selector, then it would be modified. So that was the first question you asked. I think the second question was about cleanup
and yeah, before we go to the second one, I mean, the first itself makes me feel that there are so many moving parts here, as in we need to keep track of many CRDs here, as in we need to take care of the gateways. We need to measure that if you change something on the gateway, it also gets reflected on the waypoint. So those are little concerning to me. Yeah. And it might be difficult for a normal user to probably keep a track of all of these things, wherein they will be mostly focused on like just using the application and not really managing the waypoint or the 2D version as well. That is mostly taken care by a different set of users.
That is correct. And I agree that we are introducing some moving parts here. Users could define this in a way that is extremely complex. They could also define it in a way that's extremely simple. For instance, a waypoint selector that selects everything and points to the only template. Then when you upgrade the template, everything in the cluster upgrades. What I would push back on, though, with regard to complexity is there a compelling user story that we can tell that introduces less complexity? If there is, we should go for it. It sounds like we don't want everything to automatically upgrade when the control plane does. Or maybe, Sudi, I don't want to put words in your mouth. Maybe you are advocating for everything to automatically upgrade when the control plane does. What do you think?
Yeah, I was actually thinking maybe that might be a good option, as in the way it happens with Canary. So when a new control plane comes in, the newer waypoints would be coming from the newer version, and the older one stays as is till it is either killed or restarted, or the older control plane goes away, cleans up all the other waypoints. If that is a possibility, I'm not very sure.
The restart semantics that we have today with sidecars during an upgrade have caused a lot of problems for the project throughout the years because it's not declarative. If you upgrade a control plane and then leave your pods running for, say, 3 months, and then for whatever reason your cluster, you have some node change and a bunch of pods restart, all of a sudden you just got a sudden upgrade of a whole bunch of Envoy sidecars. And you didn't ask for that upgrade. Well, you did. You asked for it 3 months ago. But it's very difficult for the user to connect their action to the change in the cluster. So I wouldn't necessarily want to replicate that behavior for waypoints. I think that's actually a problem that waypoints solve rather than a behavior that we should carry forward. Does that make sense?
Yeah.
So I think I'm next. Unless Ethan, you want to go first. I think it will be a bit longer. My concern is in Istio, we already have about 20 ways to do things, especially around install. And in reality, most people use Helm to install stuff, or they expect some managed service that was going to, things to automatically happen, like discussed earlier. Between those two options, do we need any third option? Do we need any other, more complex option? Because with Gateway, in particular, Istio already has a mechanism to create deployments, redeployments, and do all the stuff automatically. And if users choose this way, again, fully automatic is the expected behavior. If the user is okay for Istio to create a gateway with whatever deployment it wants without caring about templating and configurations, and then they already have that. And if they want full control, they can just use Helm charts for gateways that are supported and are identical for Waypoint and, or should be identical between Waypoint and Gateway, because there is nothing different between them, except one is, deployment namespace and may have an extra flag to have the HBON enabled. The other one doesn't have HBON enabled, but other than that, they are exactly the same thing. So between the Helm template, which we are not going to deprecate, and it's probably the most popular and provides the most complex configurability, and user can set whatever they would normally set with Helm, and they have no kind of confusion. And because it's not Istio Waypoint, another invented way specifically just for Waypoint, it's the same Helm fully customized as they had for Weber and all other application use. So that max flexibility. And the other one, which again Istio supported for quite a few versions, is fully automatic. Istio already has a mechanism to create deployments and configure them with whatever mechanism. And we don't change anything. There is no reason to change anything. Istio internally can create a new deployment and do traffic shifting or whatever. Can be smart about it when it does automatic. But it doesn't need user to tune anything, because then user Istio is in control. I have a hard time to believe that there is a middle ground where user wants to create some CRDs and have something half automatic, but half fully customizable. And it's a can of worms, because we'll keep adding all the options until we end up with Helm templates that we had in the first place, and no benefits, because it will be super complicated. And so I would rather initially, at least for the first few releases, stick with the two options that we have. And later on, if we find that Helm is, again, like we find in the first few years ago that Helm is not good enough and we need to invert Istio cutters, then we can maybe then reopen this proposal.
So with the Helm model, just to make sure that I understand what you're saying, Costin, if you go directly to the cluster and it's in Helm mode, you create a gateway, a Kubernetes gateway CRD, it will not have a corresponding deployment. You're responsible for creating your own using Helm. Is that what you're
Yes,
proposing?
that's just like we do today. I mean, today, if you want to create a gateway in a namespace, you do Helm install istio/gateway and do whatever you want. I mean, you have full control. You can create separate revisions. I mean, we can take, revision to upgrade is a well-defined process. Not so well for gateways, but still.
Okay.
And if you don't, I mean, most people probably will not bother with that unless they want full control. Then they have the fully automated that istio has today that we can hide completely from the user, basically. And that also allows us to put the gateways in a different cluster, have some sort of managed shared gateways, do all kind of fancy stuff that is not, will become impossible if we expose templates, because your proposal, that's a fundamental flaw with this model, is that it assumes that user will still want deployments running in the same cluster and with a, but maybe we want to run them in a different cluster, the reserve cluster, or put them, separate them somehow.
So certainly you don't have to use waypoint selectors and templates. If a pod spins up that matches no selector and you don't have a default selector, we would have no deployment correspond to that or to that gateway. And then you would be capable of scheduling a deployment in whatever system you want. You can run it on vSphere if you feel like it.
No, but why bother? I mean, if in the fully automated, we have the control to put it wherever, and in the fully controlled, it's already supported. It works. People, know how to use Helm.
Well, to be clear, it doesn't already work. It's not already supported for waypoints. Particularly when you upgrade SDOD, nothing happens to your existing waypoints. They never change.
That's a bug. I mean, that's implementation. It doesn't need an API surface change to fix this. I mean, that's clearly wrong, but it's just implementation detail, and we can implement it however we see fit.
That's true. Okay, there are a couple other comments in the thread. It looks like Ethan's up.
Yeah, I've got 3 comments. So first, this is solving a complicated problem, and as a result, it appears to be a complicated solution, which makes sense. Just in general, I'm wondering if we can delay adding the complexity until we're further along in the development process and have a better understanding of what's needed. Like, I basically agree with the requirements as a kind of GA requirement for waypoint upgrade.
Yep.
I'm skeptical of our ability to figure out what the best UX for how to organize the CRDs and all that sort of stuff is going to be today. So the first question I would have is there something we can do that's good enough for an alpha release that's much simpler, that doesn't lock us out of the correct solution later? I don't know the answer, but that's kind of my first broad question. I can keep going, or I can let you respond.
Well, I would ask, I understand that there is some complexity here, but waypoint templates already exist just in a config map. There's already a bunch of names templates, and there's already gateways that have labels. So this is introducing 2 fields in a very small CRD. I have a hard time envisioning a much simpler API than that.
And that might be true. Does the user have to understand this? Maybe from a UX perspective.
Behavior proposal that I have. The idea is that if the user doesn't understand this stuff, they perform an upgrade, their waypoints upgrade. They didn't spend any time thinking about waypoint selectors. It just happens. But if they care, if, for instance, they're in a huge production cluster and they want waves or they want different tiers of service, they have the ability to set that all up with just this 2-field CRD.
But Mitch, if they want to set tiers and whatever, they probably won't do that for all their deployments using CI/CD and advanced stuff, and they want full control. They want to update their app in the namespace, update the waypoint. I mean, they want to have full control, and that's the Helm options that we have. I mean, it's not. I don't think they want. For Istio waypoints, we use this process, but for my application and for my configs, I use a different process.
So they do use CI/CD extensively, and this would be a CI/CD compatible change. It works with Helm. What it doesn't do is actually create the deployment itself in their CI/CD, because oftentimes in a cluster, this is something we found, by the way, with the Istio GitOps demo that we sort of published as a best practice back in May. There will be a number of times that users bypass necessarily GitOps. Perhaps they're working with a Helm chart that simply does not allow them to modify the values that they want. And so a gateway gets created dynamically in the cluster. In that scenario, that gateway would just never run. There would be nothing that happens corresponding to it because it doesn't exist in Git. Does that make sense?
Let me make my last point, because I think this point is the meta problem that we're actually talking about. Kind of an original sin, which is not a problem with this proposal, it's a problem in the experimental branch, is for the first time we're using IstioD as sort of a like pod deployment management thing. And it's a little awkward because it's kind of competing with Kubernetes, which also does pod management. And it really doesn't make sense when you start to think about people have got kind of vendor versions of Istio that are going to have weird vendor-specific versions of waypoints that are going to need their own stuff. I would love for there to there's this I would love for Istio to not care about this at all, but we also need behavior that works reasonably well out of the box. So I don't know what the answer there is, but I think the debate you and Costin are having are actually fundamentally caused by this tension.
And there is a tension, as John has pointed out, that is common to all implementers of the Gateway API. If you're implementing the Kubernetes Gateway API and you're running it in Kubernetes, I suppose you could run it elsewhere, you will have this problem. You will need to respond to a gateway and cause something to execute somewhere in your cluster.
Yeah. Okay. Well, those are all my comments.
Thanks, Ethan. I think John's up.
Yeah, I think we want to kind of wrap
Yeah, I was
this
just
up.
going to say I'm pretty skeptical of supporting Helm for waypoints. I think we lose a lot of control that we have. It also effectively requires injection. I think we have it for, Istio gateways as kind of the legacy option because it was before the whole gateway API. But I think if we were to create Istio today, we would probably only have gateways, is my suspicion. So I'm not sure that now that we have a clean slate that we want to pull back in the Helm install option.
Well, we still need to fix it. But I don't disagree. I mean, ideally for first alpha, maybe we should just have the existing, completely fully automated and leave the gateway as an option. But since we have the Helm, why not keep it working?
It doesn't work for waypoints. So, I mean, a gateway and waypoints are similar, but they're different.
But that's maybe a bug, not a feature.
Yeah, I worry about making Istio less responsive to the user. Like this whole concept that we've had in gateways forever in Istio, that first you create the gateway object, then you need to also create a matching deployment. And that deployment is more or less determined by the gateway object and the control plane. We sort of added pod injection to ease that a little bit, but you still have to create the deployment to have the pod injection. I think what makes sense from the user is that we don't repeat ourselves, right? Or we don't require them to repeat themselves. If you create a gateway, the gateway should execute the way that you specified. You shouldn't need to think about how or why, etc. Lynn, I think you were saying, did you have something else on the agenda?
Yeah, there are something else on the agenda which we should get to Li-Ming soon. I actually was, as Costin was thinking, saying stuff when he raised hand earlier, I actually was thinking, how does the user deploy gateway today, right? So I sent you guys the link to the how user deploy gateway today, which they can deploy through Gateway API, which they can deploy through Helm, which they can deploy through Kubernetes YAMLs, which I think is extremely, extremely flexible. So to me, I think for the waypoint, I think it will be obvious to the user if we follow a similar pattern. Because what I'm worried about is the way that we expose like the waypoint template, and the template is another learning curve user would have to learn because everybody understands Kubernetes YAMLs and services. So that will be obvious if people need advanced customization, such as resources, such as part disruption budget that you mentioned. So I'm curious, would that be a reasonable starting point for people who need customization without introducing additional semantics and additional template for the waypoint?
So I don't think there's actually any way to disable that sort of customization in Ambient. The bottom line is if you want to control everything and do everything yourself as a user, you can schedule your own Envoy deployments and you can get them to connect to SDOD. You can give them your own initial config if you want to. We're building a solution for customers. The whole idea is behind Istio is that it's Envoy, but you don't have to do everything, right? Some of it is done for you because of the complexity of managing a fleet of Envoys and getting config to them was overwhelming for users. So the question is really one of sweet spot. What is the amount of control that we want to give to users and flexibility versus how much should we do for them and make the right decision on their behalf? I'm not sure that there's a clear and obvious answer to that question, but it's an important one to address.
Mm-hmm. Yeah, sounds like we probably should have a little bit more time to think about this proposal. Yeah.
Well, absolutely. I'm working. I was hoping to have a demo ready for everybody this morning, but it's not working yet. So I'll continue sort of honing this. I would love, especially Lynn, to continue the conversation with you around default behavior and to understand like what you think a default ought to look like, because that would be important to capture. And I'm not sure that I've captured all of that here. But this will be an ongoing effort for sure.
Okay, sounds good. So if there's no further comments, should we move to Li Ming next? Yeah, thank you so much, Mitch.
Yeah, let me present the talk. Correct. So this is actually a follow-up discussion of the previous presentation done by Yossi and Lin about the Z-tunnel L4 policy. So directionally, this is consistent with the existing proposal by Yossi and Lin. I just proposed an alternative API representation, which I think is probably more flexible. So the idea of this API proto is I actually modeled based on the existing Envoy RBAC API. So it can support recursive and or not combinations. And you can do the and match or match, not match at any level. And the implementation will also be very straightforward because this is a recursive API and there's an example Envoy implementation already exists. Unlike Envoy RBAC API, it does not introduce the concept of roles or permissions. So it's simply the role matches. Actually, the main proto is basically, I copied from UC stock. So this is consistent with what we already have. And instead of trying to model it just based on the existing Istio authorization policy, the next level of role match is basically decoupled with the control plane policy. It's simply the recursive row match. You can either have AND match, you can have OR match, or you can have NOT match. Yeah, I have an example of how we translate the ECO oscillation policy into this L4 L4 zeta node policy. So basically the benefit of having this proto is one is it has a simple proto. However, it provides the maximum flexibility. It provides like you can have any recursive and or combinations. And also on the control plane, I think the benefit is because on L7 we are going to use M1 RBAC, and it will be nice to have like a very similar implementation in the control plane for L4 implementation as well. So this will allow the code reuse in ECO control plane. And also the other benefit is it decouples control plane policy and the data plane policy. On data plane, basically on zeta node, you don't need to think about how the control policy will look like. It's simply what you try to implement is you're trying to having the and/or combinations. And it can be used by not only the ECO oscillation policy, but can be used by any policies. For example, the Kubernetes network policy or any other policy currently is based on M1 RBAC. I'll stop here and see if there's any questions.
So can you explain what is the difference from the previous discussion that, I mean, the things that is already implemented in and why would you make the change? I mean, what is wrong with what is implemented today?
Yeah, the implemented proto, I think, let me present the implemented model is it allows maximum 3 levels. You can have start with the AND match, then OR match, then another AND match. And
by the way, just making sure we're all on the same page. John actually have a very most recent implementation. I'm not sure if you're looking at the most recent one, Amy.
Yes, I actually had a rough, brief discussion with John on this topic as well. So I look at John's proto. I didn't look at the code implementation, but I think my understanding is the current proto allows the maximum is 3 levels, and then all combinations. So if there is policy, for example, I just give one example, which the current proto cannot support. For example, you want to say, I want to allow any principal except the principal except the principal name equals to 1, 2, 3, and the IP address equals to something. So basically, you have not then followed by and with a different condition, principal plus IP address.
Liman, I don't think that's accurate. The implementation I have can represent everything that authorization policy can represent.
Yeah, the existing ECO authorization policy can represent.
Yes.
The example I gave is actually not in the existing ECO authorization policy.
Then we don't need to implement it.
Yeah, I think having more flexibility is a bad part of an API, not a good part. We should have as much complexity as we need to solve the problems that we need now and in the future. I haven't heard any proposals to expand the complexity of rules that would require this.
Yeah,
like our goal is not to be an arbitrary RBAC engine. It's to implement the EC2 API, any potential future EC2 APIs, and possibly a network policy.
The ECO API can also evolve. So yeah, I'm thinking we can let the control plane policy evolve, while the data plane can just keep simple. It's only think about the and/or combination.
If the control plane evolves, which I have never heard in 4 years anyone suggesting any changes to it, then we can also evolve the data plane API. It's
Yeah, and the other thing is, yeah, sorry, let me finish. Currently, CDM policy actually support 4 level of end-on combination. So if we just limit it to 3 levels, yeah, I'm concerned. Yeah, if there is we just limit the tunnel to Istio authorization policy, not for other policies. I don't know if that's a goal or just supporting Istio authorization policy is enough.
It's our starting point.
Yeah, I think network policy is also something we may need to implement, but that's perfectly fine. I mean, I don't think it's limited by anything. However, I completely agree with John. I mean, if we want to extend Istio with any other, extra policy, we need to have a proper design to figure out what we want, how it can be implemented efficiently, how it scales, and then we can extend the proto with whatever is needed, what is a minimum change to extend it. The current problem with the generic RBAC is that it's very difficult to optimize. I mean, at least with a more restricted system, we can use a better algorithms and we can optimize it without being, having to implement a completely flexible, generic, arbitrary, and
But the implementation is very simple. I actually have the
It's simple. It's simple to do. It's simple to implement naively, but it's not as simple to implement efficiently. I mean, to scale all one to make sure that everything is done with minimum allocation and using.
Wait, the Envoy RBAC today is pretty efficient, right? I think we have done extensive performance tests also on Envoy side, Envoy RBAC. So yeah, I don't actually think the performance is a problem.
So the performance requirements are going to be totally different with Z-tunnel, like order of magnitude or more higher.
And
yeah, but the Envoy RBAC implementation itself is pretty efficient, I think.
Efficient for the use case we have, which is basically a number, I don't know how many n per, because right now the rules are applied on sidecar, and sidecar typically only implements the policy selected by that workload, not the entire namespace, or in the case of gateway, the entire mesh. And Z-tunnel is per node, so you may have a lot of policies. So I mean, the point is, it can be good enough for what we have today, but I don't think a completely generic expression language, I mean, with infinite flexibility, can be implemented as efficiently as something that is far more restricted in scope. That's my hopes. That current one.
Yeah, we don't support expression languages. Actually, if you look at the proto, it's pretty simple, right? It's actually a very small proto. And yeah, expression language, I think it will will cost some performance issues, but I don't think it's the first target at this moment. Yeah, I know John's implementation is already in, yeah, but at least we haven't done the control plane implementation yet. So I just put it here so we can still consider if there are other alternatives. Do we want to decouple the control plane and the data plane?
So John, you have the control plane implementation too, no?
Yeah, so Lehman, the thing that's confusing to me is that all the benefits that you're listing here apply to the existing implementation as well, more or less, except for the one about flexibility. So like you can say it's simple to implement, but that also applies to the current one. In fact, I would argue it's simpler given that it's a smaller API surface. It also reuses much of the same code. It's also decoupled. Like I agree, it is not as fully flexible, but I don't think that's a benefit. I think that's actually a downside of an API.
The flexibility, I don't think it's a downside, right? If you, in the future, you want to involve introduce other semantics we want to support, you basically need to change both control plane and data plane.
Sure, I totally understand your argument. I just don't agree with it, is what I'm trying to say.
Yeah, I agree with John. I mean, it's cleaner, simpler, and more likely to be to work better with a simpler implementation.
No, actually, I think this one is this one is simpler in my mind, right? It's if we need to introduce the not match in other level, right now the only not match is at the lowest level. Yeah, maybe I can bring up the other proto. Yeah, then it will be difficult to change the proto. But here it's automatically support everything.
Lehman, we can show. I put on in a comment an example of what the current one looks like, so we can compare them side by side if we want.
Okay.
Actually, maybe I'll just add it to the doc directly.
Yeah, let me. Yeah, I think I have the link to the original doc. Yeah.
Yeah, no, you can just scroll down. It's on this. It's on your doc now.
Oh, okay, okay, yeah.
So
thanks.
that's the same input, and this is the output of.
Oh, okay.
Yeah, so we can compare apples to apples instead of theoretical.
Yeah, but the data plane, I think the goal of data plane is not for user readability, right? It's trying to make the machine.
Sure, I wasn't trying to suggest that, like,
Okay.
you know, this I was just trying to show, like, side by side, so we actually have a concrete example. I agree that just because one's smaller or whatever than the other,
Yeah.
it's not.
Yeah.
But is the right one is pretty machine readable. It's just nested for loop. I mean, I'll link the implementation. It's very simple.
And nothing wrong with readable. I mean, nothing wrong with smaller or readable.
Yeah. I mean, the current one definitely can, can translate, can convert all the ESTIL authorization policy because it's designed to do that. Yeah, I'm just saying with the new proto, it actually can support not only the ESTIL authorization policy, but can go beyond.
Right. So I guess the fundamental question is, do we care about supporting future APIs beyond the ESTIL policy and network policy, or do we not? If we do care, then I agree we should do this. If we don't, then I think that we should stick with the current one. I don't know if does everyone agree with that assessment, or is there more nuance?
I would say not at the first pass. Like, for instance, how many users do we have to say we need enhancement to the existing layer 4 OSCE policy for sidecar? Right, so that's the first question we ask, which we haven't heard many users. I think it's pretty stable. If I remember correctly, we just promote that to stable. So for Ambient, I mean, we're doing this in the experimental branch, right? We want to implement the existing API first. I think has always been our top priority, Mimi.
Okay, yeah. I was looking at the Cilian network policy. I was trying to translate the policy into the new proto. I think it actually has one more layer at the end. Yeah, but if we are saying supporting all the network policy is another goal, maybe we should also consider that.
I don't think Cilium support is a goal at this moment, and we can add it maybe in V2 or later. It's not if Cilium doesn't change the API to adopt a common one.
Yeah, but once you have the proto there, I don't think it's easy to change, right?
Oh, I mean, we can add new proto. We can. I mean, it's possible to support a second proto. There are many ways to implement this. So I don't think we need to just have one proto.
Yeah. I just think we are in the early stage. So if we want to change right now, is actually the best time to change. That's why I just.
Can you maybe link some reference to the Cilium policy that we couldn't support in our translated version of OSCE policy, so that we have the reference we can refer to?
Yeah. Let me find some examples. Yeah.
Okay. Cool.
Okay. Yeah.
Okay.
Yeah. That's my
Thank you, Limi, so much for presenting this. So sounds like we can revisit this, but what John has is probably a reasonable starting point, unless you can show us like showstopper of some Cilium policy that we just couldn't support.
Yeah. Okay. Sure.
All right. Thanks everybody for joining. I think that is the last item on the agenda. And thank you, Mitch and Mimi, for presenting.
See you next week.
Yeah. Thanks. Bye.
Bye.